Good morning to all of you. We will now discuss about stacks implementation using arrays. As I mentioned in the last class, there are two ways by which you can represent stack. One by using arrays, second one by using dynamic memory allocation. There is a difference between allocating, using the storage space for implementation of stack. See, if you are using a already known data storage mechanism like arrays, then it will become static stack. In case if you are trying to implement stack by using dynamic memory allocation, means it's unlimited space. As you know that there is a limitation on the space if you are using arrays. So array will have limited space. So obviously, when you implement stack will also be limited with the size. Whereas when you implement by using dynamic memory allocation, it will take any amount of data to store it. So that's why you should decide, am I using array as a storage unit or I am using a dynamic memory allocation. What is the difference? In case of array implementation, which is called as a static stack, the size is limited, but you will be knowing the size and you will be allocating the size in the beginning itself. Whereas in case of dynamic memory allocation, you will be adding up the space as and when you require. Initially, all space which are required will not be allocated. You will be adding up the space whenever you want it. Okay. In today's class, let us see how this static stack can be implemented. So first of all, you have to understand, when you are implementing stack by using stack, means last in first out, element which came last to the stack, so that will go first, and element which came very fast, that will go last. So that mechanism you have to implement by using arrays. Okay. When you implement stack by using arrays, all properties of array will not be there. Specifically, we are interested with respect to random. Arrays permits you to access data randomly, whereas stack implemented using arrays, you should not think that actually I have used array, so therefore let me access the data randomly. No, you are using array only as a data storage, not as a data structure. So there is a difference between data storage and data structure. Data storage, I am just using this as a memory unit, whereas data structure, you are doing some operations. So random access is an operation that you are doing. So therefore you are not allowed to access any data randomly, though you are using array to implement the stack. So you are using array only as a storage unit. Okay. How exactly this will be there? So take this case. Now I have something array like this. When you declare array, the size of the array will be known to you. So in this case, 1, 2, 3, 4, 5 elements can be stored in this array. As I mentioned in the last class, here there is a small difference between the thinking that we do on a stack and implementation by using any programming language. It means, whereas in case of conventional stack, I just gave an example of a tube or a tumbler, and plates will be kept here like this. So plates are kept here and the objects will be moving, whereas the stack top, I mean the top of the vessel is fixed. I also explained with a classroom, wherein there is a fixed classroom called as a door, in which the students will be coming and students will be going. Here, if you call the students or data will be moving and coming inside, going out, whereas the stack pointer or the location at which the insertion and deletion happens, it does not move in a conventional mechanism. Whereas when you are implementing by using the computers, the alternate will happen. It means data will not move, data will be in the same position. Only the stack pointer will move. the stack pointer will move according to this. So, that is only the difference. Otherwise, conceptually it is same, last in first out only, first in last out only, but only difference is there elements move, here stack pointer move. There stack pointer is fixed, here stack pointer is moving. So, that is only the difference. Okay. If you consider here an array of size 5 elements, then I will be inserting the elements into this array. Initially, I am considering one stack pointer. Stack pointer is another variable that I am taking, which is identifying in which location the data is entered, or at which location I can do the deletion of elements. So, right now, if you consider 0, 1, 2, 3, these are the indexes of the elements of the array that you can operate as a stack. Initially, right now, this will be in -1. No elements are there inside the stack. So, therefore, this will be at a -1 status. It means no elements here. Now, on this you can do the insertion of elements, deletion of elements, and you have to keep checking overflow and underflow. Before you start writing any program, you have to take care of following. One, when you are inserting an element, you have to check whether there is a space or not. To insert element, do you have a sufficient space in the array? This is insertion. When you are doing deletion, do you have really elements to do deletion? This is called overflow and underflow. Say for example, right now after filling up all the 5 elements, you cannot insert any more elements. So, therefore, it is called overflow. See, whenever you are trying to delete an element, when no elements are there, this is called as underflow. Therefore, from now onwards, whenever you write programs for whatever the kind of data structure, you have to look for overflow and underflow. Whenever you are doing insertion, look for overflow. Whenever you are doing deletion, always associated with underflow. Overflow, in this case, if 5 elements are inserted, you cannot insert any more elements. Okay? Now, let us take this case. First, I am inserting a number called 25. As I already told you here, the elements doesn't move, only stack pointer moves. So, stack pointer is another variable I have considered logically connecting these two. These two are getting connected. I am trying to do like this. When you insert an element, so first what I do is, whenever I do the insertion, I already told you, first thing is check for overflow. If this stack pointer is already pointing to this, then it is called overflow. But right now this is at -1, so therefore no overflow. First check for overflow, then increment the stack pointer. -1 to 0. Where stack pointer is pointing, insert here. Okay. Next, insert 33. How to do insertion of 33? Again the same step. First check for overflow. Is it overflow? If SP is 4, then it is overflow. Otherwise, still some space is there like this. Still some elements can be stored over here. So, this is not overflow status. Then increment it by 1. So, therefore, now it is 1. So, what is being pointed by this stack pointer, you store at this position. 19 to be inserted. First check for overflow. Overflow means if stack pointer equal to 4, then it is overflow. Right now it is not, so therefore no overflow. Next, increment the stack pointer by 1, so therefore this will become 2. What is being referred by SP, you store here. Like this you can store another numbers. So increment this. Now it is there like this. Now we have inserted 5 elements, 0, 9 and 19 like this. Now, if I would like to insert an element, first thing is check for overflow. Overflow, since it has already reached the highest, so no more space is there for you. So therefore, you can't insert any more elements. So therefore, before checking any insertion, first check for overflow. How to check overflow? When stack pointer is already reached the highest position, then it is overflow. So that's how you should do it. Similarly, deletion. Deletion happens in this simple procedure. First thing is check for underflow. Underflow means check whether elements are there to delete or not. How to know? If SP is not equal to -1, it means you can do a deletion. Right now SP equals to 4 means there are 4 elements. -1 means no elements. 0 means actually at 0th position you have some element. I mean at least you have one element. So therefore, what is there in SP will indicate how many elements are there. So right now 0, 1, 2, 3, 5 elements are there. And when SPS become -1, you cannot delete any more elements. So like that you will be checking it up. Okay, right. How exactly the same thing what I have written right now on the board, if I would like to implement by using a simple programming, then this can be modularized. So today I am writing one program for implementation of stack by using arrays. So what are preparation you are supposed to do when you write a program? To write a program, you need to have an array which is accessible. The same array is accessible for insertion and also deletion. So therefore, better you go declare that as a global variable. And stack pointer you are using it, incrementing the stack pointer when you are doing insertion and decrementing the stack pointer when you are doing deletion. So therefore, the deletion operation and insertion operation both uses stack pointer. So therefore, what I do is I will use stack pointer as a global variable. Then I am having some operations, something like insertion, deletion, display of this thing or exit. So these are the 4 options that I usually am doing it. So therefore, I am having these options as possible kind of options. So this will be repeated. You will be asked to do insertion or deletion or like this, something like this. And I am writing 3 different modules, one for insertion, deletion and display of these things in separate functions. So therefore, it will be easy for you to understand how to write program separately. Okay, let us write the program step by step, and at the end of this video, I will be running this program in my computer, and I will be demonstrating to you how exactly this program can be executed and run with the different kinds of inputs. Okay, let us see how to write this program. Okay, so as usual, so just go for include this variable declaration, then define one array. I am calling an array, so I am calling an integer. I am calling the name of the array as stack array. I am calling it a stack array of size 5. It means you can store 6 elements, 0, 1, 2, 3, 4, 5. So 6 elements you can store in this array. I am declaring one integer variable called as a stack pointer, which is initially will be at -1. So I have already showed to you how to write this, how to use this stack pointer. All right. Okay. Now when these two are defined, now it is something like this. Now I have an array 1, 2, 3, 0, 1, 2, 3, 4, 5 like this. Then I have a stack pointer which is basically an integer. Initially this will be at -1. Okay. Now I will be writing one main function. How I am writing this main function? The main function is written such a way that it continuously asks for what is the operation are you interested to do? Are you interested to do insertion? Are you interested to do deletion? Are you interested to do display of elements? Or you would like to come out like this? Okay, only 4 options. So I am writing this main function. I am declaring one variable called option. I am doing this function infinite. I am writing this function infinite. You can make out this while unconditional loop, infinite loop. So I am clearing the screen each time. I am printing something like this, printf. 1 means insert, okay. 2 means delete, 2 means delete, 3 means display, 4 means exit. So I am displaying these 4 options. So I am asking user to select which option is interested. So, please scan his option. So, you may be interested to do insertion or you may be interested to do deletion, whatever. So, read those options. So, read that option. So, I am reading this option. I am displaying what is your choice. You will give one choice, 1 or 2 or 3 or 4. So, whatever he types, that is stored now in the variable called option, alright. Okay. Now, based on this value, based on this option value, I will be now branching into insertion operation or deletion operation or display operation, something like this. So, therefore, if option equals 1, if option equal to 1, what is that? I am supposed to do insertion. So, therefore, I am calling a function called insert. I am writing it here on the board. Insert. If option equals 2, if option equal to 2, I am writing a function called delete. I am calling a function called delete here. If option equals 3, I am calling a function called display. I am writing those 3 functions later. Next, if option equals 4, if option equal to 4, I am calling a function called exit, which is universally known. If somebody has pressed 4, then it will come out of the program, it will come out. So, therefore, I am calling a function called exit, which is a general purpose function which is there here. When you press 4, it will come out of the program. Okay. You just close this and close this. So, this is while is being closed, while I am doing it infinite loop. How to come out? By pressing 4. If you press 1, it will go to insert options. If you press 2, it will go to delete option. If you press 3, it will go for display. But if you press 4, it will come out of the program. So, this is how the program has been planned. So, this is a very simple main function that I have written. Now, depending on the branch that user has typed, you do the deletion insertion operation. So, I will be writing it over here. You can see from this. See, as I already told you, insertion, basically there are 3 steps you are supposed to do. 1, if you remember these 3 steps, then the whole stack is remembered by you. 1, when you do insertion, first thing you have to check for overflow. I mean, do you have space? First thing. Second thing is increment the stack pointer. If you have space, you have decided to insert element, then increment the stack pointer, then insert the value shown by SP. First thing, check for overflow. If there is a space, then you increment the stack pointer, then insert the value shown by SP. There is 3 steps. That's all. We will write the function now. Now, I am writing a delete function, sorry, insert function. I am writing here insert function. Since this array and stack pointer are global variables, anywhere it can be accessed. It can be accessed in main function, insert function, delete function, display function. Wherever you use, in all those functions, insert can variables can be used since it's a global variable. All right. Okay. Now, what I am supposed to do? First thing is check for overflow. How to check overflow? If stack pointer equals to 5, it has already reached up to this stage by inserting 5 elements, then it is called overflow. So, therefore, first check for overflow. If stack pointer SP equals 5, what does it mean? It is overflow. So, printf overflow. You can print something, whatever message you want, saying that actually overflow is there, insert cannot happen, no more insertion happens, something like that. You can just give some beautiful messages. So, I am giving only overflow. It means you cannot insert any more elements, it is already full. Else, what does it mean? This is not equals to 5. If SP equals to 5, it means overflow. If SP is not equals to 5 means any other number other than 5, it means still elements can be inserted. Okay. Now I am writing insert function here. So I have checked for overflow. Next step is else means there is a space. SP equals to 5 means no space. Else means you have a space. Space if you have means you can do the insertion. You are ready to go. First thing is increment the stack pointer. So therefore SP plus plus you do. Is it all right? You know that this syntax, you know. Increment the stack pointer by one position. Now what has happened? In this status, SP has become 0. It means you can do the insertion here. What data to be inserted? You ask user to give the value. So what you do is printf please enter the value. Please enter the value to be inserted. You have to read that value first of all. So scanf %d ampersand value. This value is not being declared, so therefore declare it here. Integer value. Now I have declared it. So integer value. Right? This has been declared. Now you have read that value. What I told you, third step is insert the value into the array shown by SP. Now SP is now showing at 0th position. So therefore what you can do is yes stack hyphen array of stack pointer equals to value. It means stack array of SP. SP means it is right now it is 0. Stack array of 0 means here. What is to be inserted? This value is to be transferred here. So whatever you give, assume that you have pressed 19. So 19 will be stored here. 19 will be stored here. Whatever. So that will be stored here. Is it done? Yes. I have done already. Close this. Close this. That closes the else. Then close this function. So this is very simple program that you can do for insertion of elements. Okay. Assume that you have stored it like this. 19. Right. Now I will explain this how does this program works. After this you are coming back here. And since it's a while you are clearing the screen and you are printing this. Insert 1 means insert, 2 means delete, 3 means display, 4 means exit. This is on an infinite loop. So scanf, so you will be pressing either 1 or 2 or 3 or 4. Assume that you have pressed 1 again. 1 means if option equal to 1, you are calling a function called insert. Insert I have written it here. So you are coming here, integer value I am declaring a local variable called value. Is SP equals to 5 I am checking. Is SP equal to 5? No, SP equals to 1. Sorry, 0. SP equals to 0. Here you can see SP equals to 0. So if SP equals to 5, it means overflow. Right now it is not, so therefore I am coming here. Incrementing SP. So SP is now incremented to 1 by 1. It is now it is 1. Instead of the 0, now it is 1. Now it is 1. Printf, enter the value. So ask the user to give the value to be inserted. Scanf %d. So read that value. So this value will be transferred to stack array of SP. Stack array of SP. SP equals to 1. So stack array of 1 means here. I am inserting the new value called 23. Yes, assume that he has pressed 23. So the 23 will go there. So like this, once this gets over, you are coming back here. Again while statement. So like this, you are pressing 1, you are coming here. Is SP equals to 5? No, because SP equals to 1. Else, I am operating this SP plus plus. So you are inserting. So like this, you can keep doing insertion of elements 5 times you can do. 5 times successively you can do without any kind of deletion. If deletion happened means, of course there is a space which has been created. Without doing deletion, Successively you can do 5 times. After 5 times it says no, you cannot insert any more elements because SP is already equals to 5, like that. Okay. I think as you start writing the programs, you will understand this better rather than directly looking at this. Okay. Now, let me write the program for deletion. You know that how to do deletion? Deletion of an element will happen at the position shown by SP. Insertion happens at SP, deletion also happens at SP in case of stack. That's why it's called stack pointer. So, single point, just like our door, insertion happens there, deletion happens there. Like that, insertion happens at SP. What is being shown by SP? At that position I am doing insertion. What is being shown by SP? At that position I do the deletion. Then it works as a LIFO, last in first out. Okay. What is the first step? When you are doing a deletion of an element, first thing that you are supposed to do is actually check for underflow. Underflow means, do you really have elements to do deletion, right? If no elements are there, you are trying to delete some elements from the stack, then the status is called underflow. How do you know that actually this has become underflow? Underflow will be known to you if stack pointer is equal to -1. You know that each time when you do the deletion of an element, you will be decrementing it. In case of insertion, you are incrementing the stack pointer by 1. In case of deletion, you are decrementing it. So, therefore, as and when you start decrementing it, even when you delete an element, only if one element is there, that is called 19. When you delete an element, so then SP will become -1. Next time when you try to do deletion, it will say no elements can be deleted. So, therefore, you have to write program accordingly. So, first step you are supposed to write something like this. So, first let me write this delete function, delete, 2 steps, insertion 3 steps, overflow, increment, then display, insert the value in case of insertion. Deletion, first check for underflow. If underflow is not there, then you do the decrementation of stack pointer and display it. That's it. Okay. So, first thing that I am doing is if SP equals -1. If SP equals to -1, it means underflow. You can't do deletion of elements. Else, what does it mean? Else means you have some elements. You have some elements, you can do the deletion. Before you do the deletion, say in this state, take this case. Right now, SP is equals to 1. Right now, in this status, there are 2 elements. Can I do deletion of an element? Yes, I can do deletion because the element which came last to the stack is 23. So, therefore, that will go. How? When you do the deletion, I will take out this 23 out of this box and decrement the stack pointer by 1 position. So, therefore, when you are taking it out, before you do the decrementation of stack pointer, first display what is that it is going out. So, therefore, in case of else, first display printf %d stack array by SP. It means you are displaying element which is going away from the stack right now. So, this will go off. So, therefore, this will be taken off. This is printed. Element which is coming out is being displayed. You can also print a message saying that actually element being deleted is so and so. You can beautify the print messages. I am just printing only this. So, what element is coming out, that is getting printed here. You can add up something like this. The element which is being deleted right now is this, something like this. Now, you do SP minus minus, close this, that is all. It is only 3-line program. Check for underflow, print it for your sake. then do the decrementation. That's it. Now, two small programs we have seen for insertion and deletion. Next we will see what is the display. Now, when some elements are there inside the stack and you would like to display them, how many elements are there inside the stack, you can use the display program. Basically, this display program will display content of the stack in a specific order. In what order? It is from the beginning, it's get printed. But to print any elements, you have to check whether there are some elements. How to check there are some elements? We already know about this. So therefore, if stack pointer equal to -1, no elements are there. So therefore, if stack pointer equal to not equals to -1, then you can indicate that there are some elements. So those elements are to be displayed. Okay. So therefore, here also in case of display, first of all, to display any elements, I am checking whether you have some elements. How to check? Checking like a underflow. If SP equals -1, you can just print saying that printf no elements. Are you getting this? If SP equals to -1, it means it is underflow. It means no elements to display. I can display only if it is else. Else means there are some elements. SP is not equals to -1. It may be 0 or it may be 1 or 2 or 3 or 4 or 5 in this example. But if it is beyond that, it will not permit, because when you are doing insertion, you would have checked for overflow. So therefore, overflow will be checked by insertion, underflow will be checked by deletion. Similarly, to display elements, to display anything, there must be some elements. First of all, I am checking whether you have elements or not by using this. So SP is equal to -1 means no elements. Otherwise, you have some elements, print those things. Else, I am writing this for I equals to 0, I less than equals to SP, I plus plus. What I am doing is, I am doing printf %d stack array of I. I am printing each element till this I reaches this stack pointer. Since I have declared, declare this variable. I have used I as one of the variable. So therefore, you can declare that as a local variable there, int equal to I, int I. That's it. Close this else, close this. Okay, so this is a very simple program I have written on the board, and at the end of this video, I will be showing you how this program works by using my computer. I have already recorded this. Okay, I will show it to you. Now, this is a fairly simple program. Now, rest of the programs in the data structure will be looking like this only. So, you will be doing some main function, and you will be doing insertion, and you will be doing some deletion, insertion operation, deletion operation, and some kind of display operation for most of the data structures. So therefore, first program that you are learning in this particular subject should be very, very thoroughly understood by you. Then you will be very easily following the rest of the data structures. Okay. So we will just close this session now, and we will see that in the next class. In the next class, I will be explaining to you how the similar kind of program we are doing this for dynamic storage. In this case, I have considered fixed sized array, where I am not considering the fixed sized array. There is no limit on the size of the data. So therefore, obviously the program I am modifying for that is there will be no overflow. You don't worry about the space, because it is unlimited space. So therefore, overflow I need not have to check. It is only this kind of program that I have to write. But underflow will be there. Underflow will be there. So you are trying to delete an element if there are no elements. That underflow will be there. But overflow will not be there, because no size limit. So we will see that in the next class. The program written on the board is now shown with a compiler editor, Turbo C++. So the same program has been written here with the same kind of variables being written on the board. You can see it consists of 4 options: insert, delete, display, exit. You have basically 3 functions. One insert function. In case of insert function, you will be checking for overflow first. So then value will be asked to enter, and that value will be inserted into the stack if there is no overflow. Similarly, in case of delete, first we check for underflow. If it is underflow, we come out, otherwise we delete element. And in case of display, if there are any elements in the stack, so those things will be displayed over here by using this simple function. Now we will run this program, and we check for all possible cases. So when we run this same program, you can see on the screen 4 options: insert, delete, display, and exit. So we will check with overflow. Since the size of the array is taken as 5, you cannot insert any more elements more than 5. So we will try to insert, delete, and simultaneously after doing some insertion, you can do deletion also. We will see all possible cases. So first we will start inserting some elements by pressing 1, enter the value. So we will enter 10. Now value 10 is inserted into the stack, and I will insert one more element by pressing 1. So enter the value, let's say 20. So now there are 2 elements. We will add one more by pressing option 1. So we will have 30. Now there are 3 elements you can display by pressing 3, option 3. Now you can see there are 3 elements called 20, 10, 20, 30. Now I can do the deletion now also. So I'll do the deletion. So when you do deletion, 30 is eliminated. Now you have left out with only 2 elements. You can see display by pressing 3. So 10 and 20. Now you can add up further more elements. So we have seen insertion of 3 elements, deletion of 1 element. Now you can keep adding. When you add next element, it will be sitting after 20. So you can see from this now, I will insert 1 element. So value to be inserted is called, let us say, 40. When you insert element, now you have 10, 20, 40 in the list. By pressing 3, you can check 10, 20, 40. Now I'll add one more element. So the element will be 50 now. So what is there in the stack now is 10, 20, 40, 50. I'll do one more insertion. Let's say 60. Now if you do display, you can see 10, 20, 40, 50, 60. If I try to insert one more element, it says overflow because you cannot add any more elements more than 5. So that's how it works. When you go for deletion, you have to check for underflow. Underflow means you are trying to delete some elements from the stack when no elements are there. But right now there are 5 elements. So you remove all the elements. After 5 elimination, after 5 removal, you can see it says underflow. So I will delete 1 element. Now 60 is eliminated. You can see from this. I will display the content. Now 10, 20, 40, 50. I will keep removing 4 elements. 2, 50 is eliminated. Now I will 40 is removed. I will do once more. So now 20 is deleted. Now I will do deletion again. 10 is removed. Now there are no elements. If I do deletion of element from the stack, it says underflow. It means the stack is working for all the cases: overflow, underflow, insertion, deletion, and display. Now after checking all the possibilities, you can press 4 and come out of the program.